Hello, good afternoon, students.
Good afternoon, madam.
Right. So, today we are going to continue lecture number 4, consistency of system of simultaneous homogeneous equations. Right. So, I think you can remember last week we have commenced this lecture. Right. So, under this lecture, we have gone through and clarify some of the terms, right? So, especially when you look at the topic consistency of system of simultaneous homogeneous equations. So, most of you guys are new for the consistency and homogeneous up to last week. So then we clarified actually what do you mean by consistent and what do you mean by inconsistent. So once again, if I review under the consistent, a system of equation is said to be consistent if they have one or more solution, right? If a set of equations have at least one solution, then it is consistent, at least one solution or one unique solution. Then that set of equations are said to be consistent. And also, there are set of equations or systems of equation where they have several solutions, right? More than one solution. So that is also consistent. And although you will find system of equations where they have infinite number of solutions. So that is also coming under the category of consistent, right? So what do you mean by inconsistent there? Right? If a system of equation has no solution, it is said to be inconsistent, right? If the set of equations has no solution, so that is called as inconsistent. So within this lecture, we are mainly focusing on consistent, right? Consistent. So therefore, so the systems of equation that we are dealing within this lecture is always have either unique solution or infinite number of solutions, right? So homogeneous means a polynomial is homogeneous if all its terms have same degree, right? So later on we clarify what you mean by degree, and so if almost all the terms have are in same degree, so that is considered as homogeneous. So we are looking at consistency of simultaneous homogeneous equation. So when we are given a set of equations, simultaneous equation, so that should be consistent and also homogeneous, right? So if we have those conditions satisfied, so if we have set of equations where they satisfy both consistency and homogeneity, so then we are coming again into two conditions. One is if D is equal 0. So here D is what? D is the determinant, right? So D is the determinant. If D is equal 0, right? If D is equal 0, then the system of equations are consistent with infinite number of solutions, right? D is equal 0, then system of equations are consistent with infinite solution. If D is not equal 0, then the system of equation is consistent with trivial solution. So we'll go to this one. This will, so this taxonomy will easily show you these two classifications. So that we have the determinant of a given matrix, right? Matrix determinant right? If the determinant is equal to 0, right? So only two cases are there, equal to 0 and not equal to 0, right? So if it is equal to 0, consistent with infinite number of solutions. So that means if D is equal 0, you will be having infinite number of solutions. If D is not equal 0, once again it is consistent with unique solution or a trivial solution. So here in both cases, under the homogeneous equation, both cases are consistent. They become consistent. But when D is equal 0, infinite number of solutions. And when D is equal, not equal 0, you will be having unique solution or as the trivial solution, right? Okay, so these are the two things that we are going to identify for a given matrix, right? System of equation is consistent if there is at least one set of values for the unknowns that satisfy every equation of the system. Excuse me for a while. Right. So the system of equation is consistent if there is at least one set of values for unknowns and satisfy every equation in the system. Okay. So you know already what do you mean by consistency. So anyway, in both of these divisions, right, both are consistent. No inconsistencies here. Then මෙතනදී අපි inconsistency කියන concept එක ගැන හිතන්නේ. All are consistent. So the difference is when d is equal 0, you will be having infinite number of solutions. And when d is not equal 0, you will be having unique solution. Right. So, example, find values of lambda for which following system of equation is consistent and has non-trivial solutions. Right. So, what they're asking is here you will be having. So you can see there. This is a set of system of equations. So three simultaneous equations are here. So what they ask you to find is the lambda, right? Based on the hint, right? Based on the factor, the system of equation is consistent and has non-trivial solutions, right? Non-trivial solution. So what we have to do? So you are supposed to find lambda. ඔයගොල්ලන්ට find තියෙන lambda. Right? In order to find lambda, the hint that they are providing is system of equations is consistent and has non-trivial solutions. So anyone, so please suggest me what we will be doing as the next step or what is the basis for this one. Hello? Hello? I didn't get your answer. By finding values of x, y, z initially. Right. So in order to find x, y values initially, so right. So that means this is a direct message for me. So one is suggesting to find x, y value initially. So that means I think he is suggesting his suggestion is find x, y, z, and then you have to find lambda. So any other using Kramer's rule. So that is another direct message using Kramer's rule. Okay. So any other answer? I'm getting x equals 0, y equals 0, z equals 0. Another direct message says x equals 0, y equals 0, z equals 0. Any other answers? So what they are asking is to find lambda. Remember that. What they are asking is to find lambda. ඒගොල්ලෝ කියන්නේ lambda හොයන්න. ඒගොල්ලෝ දීලා තියෙන hint එක තමයි, right? Or the factor that you have to use in order to solve this question is, so this particular set of system of equation has non-trivial solution. Another answer. Convert this to determine structure and that equal D and solve. Convert this to determine the structure and that equal D is equal 0. And solve. Right. So here is another direct message. I think he is saying, so convert this. So the first part I didn't get, actually, it's not much clear. But what he is saying is, make D is equal 0 and solve. So actually that is the answer that I am expecting. Right, student? So one of you are suggesting me to use the Kramer's rule. Right? කෙනෙක් කියනවා Kramer's rule පාවිච්චි කරන්නලු. Right? Another suggestion is So you have to find x, y, z initially. So I'm asking all yes, true. So in order to find x, y, z values, you can use Cramer's rule. ඒකනේ ඔයගොල්ලෝ කරේ x y z හොයන්න තමයි ඔයගොල්ලෝ Cramer's rule පාවිච්චි කරේ. But in order to, right, when we are using Cramer's rule, right, when we are using Cramer's rule හොයද්දී අපි මොකද කරේ? Right, first we need to convert this set of equations to a matrix form, right? Matrix form එකට convert කරගන්නට ඕනේ. So here but since I do not have the lambda in my keyboard, other than that I am using k. එතකොට මම දැන් lambda වෙනුවට use කරනවා k. Right? So first what we have to do is first we are going to convert this particular equation, three set of equation to a matrix form. Right? K minus 1. 3k plus 1. 2k. Right, so as the next second row, k minus 1 once again, 4 lambda, 4k minus 2, k plus 3, 2k, 3k plus 1, k minus 1. Right.
Madam, මෙතන third row එකේ දෙක විතරක් නෙමෙයිද?
Sorry. And ඊටත් කලින් තියෙනවා වෙනස් වීමක්. This should be 3. No k, and here this should be 3 times. Here k minus 1, 3k minus 1. Right? Right. So if you are going to use Cramer's rule to this, so do you know k here? Without knowing k, can you go further? k දන්නේ නැතුව ඕගොල්ලන්ට මේක proceed කරන්න පුළුවන්ද? Right? The barrier k or lambda, so in my case it's k. So without knowing k, you can't go forward. Right? Either using Cramer's rule or whatever, you can't go forward. So in the Cramer's rule, what we are doing, d1 divided by d for x, d2 divided by d, right? d3 divided by d. But the problem is you do not know this k or lambda, right? So then other than going for that solution, there should be another way. Because so if you are using Cramer's rule, then why they have given this hint? මෙන්න මේ hint එක දුන්නේ ඇයි? Right? So this set of equations have non-trivial solutions. So if we go back, here, right, you can see for the trivial solution, what is d? D is not equal 0. For the trivial solution, d is not equal 0. But so then if this is trivial solution, so this side should be non-trivial solution. May the trivial solution now make it non-trivial solution may not. So since they are saying this set of equations have non-trivial solutions, so that means, so for this set of equations, d is going to be equal 0. So the coefficient matrix created out of these three simultaneous equations the determinant of this coefficient matrix is going to be equal 0. So that is where you are going to start to solve this particular question. එතනින් තමයි ඔයගොල්ලෝ මේ question එක solve කරන්න start කරන්නේ. So this is the procedure. මේක තමයි solution එක. So since they are saying there is a system of simultaneous equations, right, where they have non-trivial solution. Non-trivial solution කියලා කියන්නේ they have infinitely many solutions. So infinite many solutions means d is equal 0. So therefore, what we can do is we can find d, right? We can find d. So that means we create our d matrix, we write the coefficients of our d matrix and we make it equal to 0. එක බිඳුවට සමාන කරනවා. Right? So then we know how to solve for d. අපි දන්නවනේ d හොයන්නේ කොහොමද කියලා. We know how to solve for d. Right? So then by solving the left hand side, so you will get this one. 6 lambda squared minus 8 lambda plus 2 minus 10 lambda minus 2 is equal 0. So if you simplify this one, you will get 6 lambda squared minus 18 lambda equals 0. So when you factorize this, so then you will get lambda equals 3 and lambda equals 0. So that means there are two values for lambda, 3 or 0. So the main thing that you need to identify is, so this particular hint. Based on this hint, you are thinking whether the d is going to be equal, whether the d is equal to 0 or d is not equal to 0. Since it's non-trivial solution, d is equal to 0, right? So that is how you are progressing with this particular question. Okay. So then, yeah. So this is much more detailed version of the taxonomy than the previous one. කලින් taxonomy එකට වඩා මේක ඊට වඩා detailed taxonomy එකක්. අපි කියන මේ වගේ, so it's a branches, we call it like taxonomy, right? So system of 3 simultaneous linear equation with 3 unknowns, right? If you have, so it's like the previous case, මේ වගේම තමයි, right? So here you have 4 unknowns. With unknowns normally x, y and z. So these are 3 unknowns. Other than that you have lambda. But here they are specifically saying, right, system of 3 simultaneous linear equations with 3 unknowns. So there are equations with 3 unknowns. Equation set එකක් තියෙනවා නොදන්නා පද 3ක් එක්ක, right? Equations with 3 unknowns. So mainly there are 2 divisions දෙකයි, right? So if d is not equal 0, then you have consistent with unique solution. ඒ කියන්නේ මේක මේ side එක. So now it's on the other hand side. Then taxonomy ke department marula තියෙන, but right, the sides are changed, but the meaning is same. When the d is not equal 0, you have unique solution, right? That means trivial solution. So same thing here, right? When the d is not equal 0, right, consistent with unique solution, right? So when the d is equal 0, now again d is equal 0 case is divided into 2. කොටස් දෙකකට බෙදලා තියෙනවා, right? So first thing is, if d1 d2 d3 is equal 0, so where you find this d1 d2 d3? මේ d1 d2 d3 එන්නේ කොහෙද? Where do you find this d1 d2 d3? Hello. Students, where do you find this d1 d2 d3? කවුරුද නැද්ද? d1 d2 d3 එන්නේ කොහෙද? හම්බෙන්නේ කොහෙද? Hello students. From 3 unknowns. No, I am asking, so from the past knowledge with the matrices, where did you find d1 d2 d3? මොන calculation එකේදී ඔයගොල්ලෝ d1 d2 d3 එන්නේ? I just mentioned it.
Kramer's rule එකේදී
Kramer's rule again, right? So under the Kramer's rule calculation, you will find this D1, D2, D3. So අනේ D1, D2, D3 ගැන තමයි මේ කතා කරන්නේ. So D1, D2, D3 is equal 0. So when D is equal 0, right? When D is equal 0, right? With that, if D1, D2, D3 is equal 0, definitely you will get consistent with infinitely many solutions. And also there's the fact that D1 or D2 or D3 is going to be equal. So then that is considered as inconsistent. There you will find inconsistence, right? So mainly there are two types. When D is equal 0, as we have learned previously, consistent with unique solution. When D is equal 0, you will be having unique infinite many solutions. Again, we are going to divide it into two. So with the D equals 0, if D1, D2, D3 is equal 0, right? Everything is going to be 0. Everything is going to be 0. And you will be having infinitely many solutions. So non-trivial solution in method. Right? But may D varga tune එකක් හරි බිඳුව වෙනවා නම් ඔක්කොම නෙමෙයි D1 or D2 or D3 sorry is not equal 0 එකක් හරි බිඳුව නොවෙනවා නම් then that is considered as inconsistent, right? Okay, so we will go to a so same thing here they have mentioned in words. So this I think this taxonomy is much more clear than words. If you go through the words, if D is equal 0, D is not equal 0, right? D is not equal 0, then the given system of equation is consistent and has unique solution. If D is equal 0 and all the other D is also 0, then the system of equation is consistent and has infinite many solutions. Right? If D is equal 0 and at least one of the determinants, D1, D2, D3 is non-zero, then the given system of equation is inconsistent. Same thing. Right? Okay. Test the consistency of following equations and solve them if possible. Right? Balanna, mega kiyana vidiya. Test the consistency of the following equations and solve them if possible. Right? So here this particular question has two parts. First thing is you need to test the consistency and next thing solve them if possible. පුළුවන් නම් විතරක් solve කරන්න. එතකොට so how are you going to judge whether this set of equations can be solvable or not? මේක solve කරන්න පුළුවන්ද නැද්ද කියන එක හිතාගන්නේ කොහොමද? From this test. Consistency test again right? So in the exam also, so we have a lot of experience that when we give the set of equations like this, so listen that up. They straight away go and apply Kramer's rule, right? So you know that in the Kramer's rule also, you need to find 4 determinants. D, D1, D2, D3. So altogether 4 determinants are there and also, so after that you need to find D1 divided by D, D2 divided by D and D3 divided by D. Right? So considerable amount of calculations are there. Right? So, but what they are saying is, test the consistency, then only you need to solve them. If there's a problem with the consistency, you can solve them. solve so in the midway, they understand that you can't solve it. But then you are too late and you have wasted so much of your time. So that's why first you need to check the consistency and then go and solve the question. That's why I am always saying, under the test, so how you are going to test the consistency? Through the determinant. Consistency balance determinant. Right? So that's why in the Kramer's rule, whenever you get a Kramer's rule, a question to apply Kramer's rule, First thing is you need to find D, not D1, D2, D3. First thing is you need to find D. Based on the answer that you will find for the D, you can determine whether to proceed or not, go forward or not. Right? So that is important. So test the consistency of this set of equations and tell me what happened to the determinant. One answer I got is 29. Any more answers? Sorry. What your message? Again, 29. Right. So it seems that you will be getting 29 as the determinant. If so, what you can say regarding the consistency, whether is it consistent or not, or how you are going to proceed with the set of equations. So actually 29 means D is not equal 0, right? D is not equal 0. So what can you predict about the number of solutions it will have? Whether it has a unique solution or whether it has an infinite number of solutions. What is the case? Whether it has a unique solution or infinite number of solutions. Right? If D is not equal 0, right? D is not equal 0. So that means, right? D is not equal 0. It has a unique solution. If it has a unique solution, that means it is solvable, right? So then solve and tell me what is X, Y, and Z using the Cramer's rule. So since you got 29, therefore D is not equal 0 and you can proceed with. But by the way, if you got D is equal 0, right, D is equal 0, again you will be having a problem whether it's consistent or not. So if D is equal 0 and all the other D1, D2, D3 all are 0, so then definitely they have infinite number of solutions with consistent, but at least one of the D is not equal 0, so then it is not consistent. So since this is consistent have unique solution, you can find the answer. So tell me the answer. One answer I got is X is 58, Y is mine, no, 29, Z is minus 116. Any other answers? X is 2. So remember that after you you have found x d1, d2, d3, you need to divide it by d, right? D1 x is going to be equal d1 divided by d, y is equal d2 divided by d, and z is equal d3 divided by d. So exactly what you have done under the basic maths, right? So x is equal to, y is equal 1, z is equal -4. Any other answers? X is 2, y is 1, z is -4. Okay. Right. So I'm going to the answers. Right answer D. D is 29. Yes, true. You gave me the answer as 29. Okay, now answers are coming. Right. So by the way, D is 29 and D1 is 58. D2 is 29 and D3 is minus 116. So x is d1 divided by d, 58 divided by 29, which is equal to y is equal d2 divided by d. So that means you need to divide 29 out of 29, which is equal 1. And z is equal d3 divided by d, which is equal to minus 116 divided by 29, and it is equal to -4. So finally, x is 2, y is 1, and z is -4. So these are the answers, and I think most of you have come up with this answer. Okay. So with that, another method, so with adjoint method to solve linear equations, right? So I think at the very beginning, I told you about that adjoint method. So you know how to find that joint, right? You know how to find that joint. So normally, with the coefficient matrix, whenever we are given a set of equations, right? By using the coefficients of the equations, we construct our original matrix. Coefficients වලින් දීලා තියෙන equations අපි තුනක් නම් තුනේ coefficients පාවිච්චි කරලා අපි original matrix එක අපි හදාගන්නවා. So later on, so we can find the minus, and then with the cofactor matrix, right, then we can convert the cofactor matrix to the adjoint matrix. And from the adjoint, when adjoint is divided by the determinant, we got what? Adjoint divided by the determinant, we got inverse of that particular matrix. So actually that is the method, that is the basic idea where we are using here under the adjoint method. Adjoint method එකේදී අපි පාවිච්චි කරන්නේ අන්නේ concept. Right? We are going through what the inverse, right? Depending on the inverse. We are not using the Cramer's rule in order to solve the set of linear equations. You can either use the Cramer's rule or this particular adjoint method. So here you will see, you will have the set of equations, 3 set of equations. And out of these 3 set of equations, by using the coefficients, they have constructed the coefficient matrix A. A is the coefficient matrix. Capital X is the 3 unknowns that you are going to solve, right? Are the 3 unknowns that we have to solve, X, Y, Z. And capital B is equal to whatever on the right hand side of the 3 equations, right? Equations තුනේ දකුණු අත පැත්තේ තියෙන ටික තමයි D1, D2, D3 තමයි මේ capital B කියලා අර්ථ දැක්වෙන්නේ, right? Capital A is the coefficient matrix, capital X is the 3 unknowns where we need to solve, and B is this D1, D2, D3, right? So here they are telling, right? So actually what is this? ඇත්තටම මේ set of equations ගත්තොත්, right? Set of equations ගත්තොත් මෙතන තියෙන්නේ, so within this equation මේකේ foundation එක වෙන්නේ AX equal B. A කියන coefficient matrix එක, X කියන unknown values තුන තියෙන matrix එකේ. That means when තියෙන column matrix එක, right? So when a matrix is multiplied by this particular column matrix called X, you will get the answer as the B column matrix, right? When A multiplied by X is equal B. So that is the basic idea. So what do you want to here find? What is your ultimate target? So here your ultimate target is finding X, Y, and Z. That is actually what you are doing under the Cramer's rule also. Cramer's rule එකෙන් කරන්නේ ඔකම තමයි. In order to find X, what you are going to do, D1 divided by D. In order to find Y, what you are going to do, D2 divided by D. In order to find Z, what you are going to do, D3 divided by D. So that is what you are doing, Cramer's rule, and there also your target is to find X, Y, Z. So here also in the adjoint method also we are using this method in order to solve this set of linear equations. Solving means we need to find X, Y, Z. Method of කරන්න යන්නේ X, Y, Z වලින්ම තමයි. But the problem is here A is equal B. So here we need to subject X. අපිට මේ X subject උත්තර කරගන්න ඕනේ. Right? So then basically what we have to do අපිට බැලුමට නම් පේන්නේ අපි මොකක් කරන්න ඕනේ කියලාද? Right? Here we have AX equal B. Right? So normally what you have to do, we need to divide both left and right hand side from A in order to X. Put X ganna, what we need to do? A divided by B divided by A. Right? So that is what we need to do. Right? But the problem is you already learned that, right? So under the matrices, we are not defining something called division. අපි division ගැන කතා කරන්නේ නැහැ matrix ඇතුලේ. Right? We are talking about the addition, we are talking about the subtraction, we are talking about the multiplication, but we are not talking about the division under the matrix. Right? Instead of division, what we are talking about? Right? What is the replacement of the division under the matrix? Anyone? Inverse. Right? එහෙමනම් අපි කරන්න ඕනේ inverse ගන්න එක. Right? So next the solution is we need to get the inverse. Right? So I am getting the inverse from both sides in order to subject X. X උක්ත කරගන්න. එහෙනම් මම inverse ගන්නවා. Right? So I'm putting inverse like this, right? A to the A inverse times A times X is going to be equal A to the power like this minus 1 times B. Sorry, B. Right here, you should notice this, students. Right here, I place inverse at the beginning. Right here, I place inverse. Right here, I place inverse. A inverse කියන එක මම place කරේ AX වලට ඉස්සරහින්. Right? In front of A inverse, here also the same. In front of B, I put A inverse. Right? Not after the B. Right? Because the place matters. Under the matrix, we know that commutative law is not relevant to the matrix. A multiplied by B is not equal B multiplied by A. So therefore, place is very important. Right? Here you will understand here, A inverse times AX is equal A inverse times B. Right? So actually you know that A inverse times A inverse again value ko naam uttare මොකක්ද? When A inverse multiplied by A, what is the answer? I. Identity matrix. So identity matrix times X is going to be equal, right? Going to be equal A to the power A inverse times B. Right? So again we know that if a particular matrix is multiplied by an identity matrix, what will happen? For example, identity matrix times X. Here what is the answer? X. ඕනම matrix එකක් එයාගේ identity එකෙන් වැඩි කරොත් උත්තරේ ඒ matrix එකම තමයි. ඒක හරියට අපි ඕනම සංඛ්‍යාවක් එකෙන් වැඩි කරනවා වගේ. So it's like in the real number world, whenever we multiply any number with 1, so we will get the same number. Right? Likewise, under the matrix world, there is no ones there. Other than that, unity matrix is there. Right? So, or as identity matrix is there. Whenever we multiply any matrix with its identity matrix, then definitely we will get again the same matrix. So here we will get, right? Here we will get A inverse, right? A inverse times B. Right. So now you will notice that. So here we'll automatically subjected x. Then x sukta vela thiyenne. Right. So in order to get the x on the right hand side, we need to do this calculation. So that means you need to find A inverse. So here on the right hand side, you need to find, you have the multiplication in between A inverse and B. So in order to do this particular multiplication, first you need to find A inverse. In order to find A inverse, you need to first find out the adjoint matrix and then only you divide it into determinant. So that's why this particular method is called adjoint method to solve the linear equations. Right? Ekai megata adjoint method to solve the linear equations kiyala kiyanne. So here you find the inverse, A inverse, and then you multiply that particular A inverse with the matrix B. Then you will get this, what is X, what is Y, and what is Z. So that is another method. You can try by yourself, right? For the same matrix. අපි කරපුම example එක ඔයගොල්ලෝ මේක මේ විදිහට solve කරන්න පුළුවන්. Here also one thing you will notice that. So I think you initially when I talking about the inverse, I told you that if a particular matrix is singular, so what do you mean by a singular matrix? Singular කියන්නේ මොකද්ද? What is the mean by?
Determinant is 0.
Determinant is 0, right? So if the determinant is 0, are we able to find inverse? Can't. Because in order to find the inverse, we need to divide the adjoint matrix by the determinant. Right? If the determinant is 0, we can't find the inverse. So here also, although consistency is directly not coming to here, right? But actually it's there. Determinant right? Before you are attempting this calculation, since you need definitely determinant you require, because in order to find the inverse, definitely determinant you want to find the determinant. So therefore, before you going into this much detail, so you can initially find the determinant of this original matrix, which we have created using the coefficients of these three equations. So whether that determinant is going to be equal 0 or not. If it is not equal 0, that means yes to you can proceed. Right? Because then you can divide the adjoint by the determinant. But if any chance, if determinant is going to be became 0, that means you can't go proceed with it. So from there you can stop, right? So here also in the adjoint method to solve the linear equation, what I'm recommending you is first you can check whether determinant is 0 or not. If it is not 0, you can go ahead, right? Otherwise you can stop by saving a lot of your times. Okay. So that is basically the adjoint method to solve the set of equations. You can use either method, but if you are asked to use specifically the adjoint method, yes, definitely you need to use that method. But if the method is saying you need to use the Cramer's rule, yes, you have to go to use the Cramer's rule. But if within the question, if I'm not specifying any particular method, then you can use either Cramer's rule or adjoint. Okay, so solve with the help of matrices the simultaneous equations, right? So So it's 2 here, right? So here also, so this is, so okay, you can try, right? So I'm giving you just 5 minutes, right? You can tell me what's the determinant and then I'll show you the rest. So for these particular three equations, find and calculate and tell me what is the determinant. So now we are going to look at the adjoint method, how to solve a given three set of equations using adjoint method. So then tell me what is the determinant of these three equations. I got one answer as 2. Any other answers? Okay, it seems answer is 2. So we'll proceed. Right. So the given equation, set of equations is converted in this matrix form, right? So that this is the coefficient matrix and this is the capital X matrix and B, two column matrix corresponding to the X and capital B. So here now, in order to find this X, capital X or X, Y, Z, three components, the unknowns, you need to find out what is A inverse, right? So the first step is, now you can see the first step is to find the determinant, right? First step is to find the determinant. Now the determinant is equal to, right? So then you have to find the minor cofactor matrix and then you have to transpose this cofactor matrix in order to get the adjoint, right? This thing you know, right? Cofactor transpose adjoint. Then in order to find A inverse adjoint matrix divided by determinant, right? Adjoint matrix divided by determinant. So this is finally the A inverse. That make it A inverse is. So now what you have to do in order to get the X subject X, right? So you multiply both sides A inverse. X equal A inverse time B. Right? So now you are going to do the calculation X equal A inverse time B. So what is the A inverse? So this is A inverse, right? So this is the A inverse. So that A inverse is half times this particular thing times B. So what is B? Right? What is B? B is 3, 4, 6. So this is the right hand sides of the equation. B, how you are going to form the B? B column matrix 3, 4, and 6. So now B is equal 3, 4, and 6. So here the column matrix consists of 3, 4, and 6. Now you can see the inverse matrix is multiplied by B. Right here you can see inverse matrix. So the dimension of inverse matrix is what? 3 by 3. Right? Make a dimension 3 by 3. And here this particular column matrix 3 by 1. Right? 3 by 3 multiplied by 3 by 1. So multiplication is possible. So what will be the dimension of the resultant matrix? Resultant matrix dimension say now what when on 3 by 3 multiplied by 3 by 1. What is the output dimensions of the output matrix?
3 by 1.
3 by 1. Right, 3 by 1. So now you can see after multiplying these two, this is the final result. Make a final result. Make a 3 by 1 matrix. It's again a column matrix consisting of 3 rows and 1 column. 3 by 1 matrix. So X is corresponding to 2, Y is corresponding to 1, Z is corresponding to 0. So this is the adjoint method to solve the set of simultaneous linear equations. So some may found that this is much more easier than Cramer's rule. Somehow make a lazy. Yes, it's up to you, but again I am saying in the paper, if I'm specifically asking you to do the calculate using the Cramer's rule, you need to use the Cramer's rule. But if I'm specifically asking you to use the adjoint method, you need to use the adjoint method, right? But if I'm not mentioning any particular method, you can use either Cramer's rule or an adjoint method, okay? But remember, right, so mostly under the questions I'm mentioning, use a matrix method. So otherwise you can use the traditional method, right? Equations තුනක් solve කරන්න ඔයගොල්ලන්ට traditional ඔයගොල්ලෝ 10 වසරේ 11 වසරේ කරපු method එක use කරන්න පුළුවන්. There we will use same matrix method නම් මෙතන බලන්න solve with the help of matrices. එතන කියනවා solve the simultaneous equations කියලා නෙමෙයි කිව්වේ. Right, question did say that solve the simultaneous equation, but they have added something, solve with the help of matrices the simultaneous equation. So that is definitely you need to use a matrix method to solve this set of equations. It can be either Cramer's rule or an adjoint method. Okay? Right, so that marks the end of lecture number 4. Right, so next thing is lecture 5. Right, so eigenvalues, right? Eigenvalue is an important part of the matrices, and also this is one of the lengthy lecture guide, right? We need to learn about four different type of eigenvalue calculations, right? So have you any experience regarding eigenvalues before? Calling eigenvalues සම්බන්ධ මොනවා හරි calculations ඔයගොල්ලෝ කරලා තියෙනවද? Anyone? Right, anyway. So what do you mean by an eigenvalue, right? What do you mean by an eigenvalue? So actually before going through the detail, so one answer, no, answer is no, right? So here, so you may be wondering why we need eigenvalue based calculations. If I'm asking you to do a calculation like this, for example, let's say you will be given a matrix, 3 by 3 matrix, right? You will be given a 3 by 3 matrix, and you are asked to find the 6th power of this matrix. For example, let's say, so you will be given a matrix called A. I'm asking you to calculate A to the power 6. A to the power 6. Right? Or A to the power 8. Right? So, what you are supposed to do? Right? So, it seems that you need to do matrix multiplication. That means if it is A to the power 4, you need to multiply the same matrix 4 times. A multiplied by A multiplied by A. But you know, right, how hard you to multiply even 2 matrices. Matrix එකක් multiply කරන්න කිව්වත් කොච්චර අමාරුද කියලා ඔයගොල්ලෝ දාන්න. But so in that scenario, if I ask you to multiply 6 matrices together, 8 matrices together, what will happen? Right? Seems, right? You will come across a lot of errors, and it seems it will take a lot of time. Right? So for those sort of problems, we can easily address those sort of problems through these eigenvalue calculations. Right? We are learning something called diagonalizing, right, and powering. Right? Those two concepts are coming under this eigenvalues, right? So that is so. Before coming to the lecture, this is the use. So I'm telling you what are the advantages. Basically, to get a power of a particular matrix, not just A to the power 2, but A to the power 4, 5, 6, 7, 8, 9, 10. So not to get that much, go that much beyond, right, you will be using the concept of eigenvalue easily. Right. So here A is a matrix, X is the column vector, this one, right, and Y is the column vector again, right? Now we have experience regarding AX equal Y format. And again, because under the adjoint method of solving the set of linear equations, we master this, right? So we know what is A, the coefficient matrix, X, whatever the unknowns we need to solve, and Y. Y is whatever the values are on the right-hand side of the set of equations, right? Here the column vector X is transformed into column vector Y by means of a square matrix A. Okay, let X be a such vector which transform into lambda X by means of transformation. Suppose the linear transformation, whatever, right? So we'll see like this. We know that AX is equal Y. Again, students, instead of lambda, I am putting K. Lambda වෙනුවට මම K ගන්නවා, right? Okay, දැන් අපි originally දාන්නවා AX equal Y. AX equal Y. So here what we are doing, AX equal, instead of Y වෙනුවට අපි කියනවා lambda X. So in my case, it is Kx, right? මට lambda ලියන්න බෑ. Kx. Sorry. Oh, yes, Kx. Right? And also, I can write like this. AX equal K means my lambda, times Ix. Instead of X, I am writing Ix. Is it correct or wrong? So what is I here? If x can be written as ix, then what is I here?
1.
Any other answers?
Identity matrix.
Identity matrix. X කියන එක ix විදිහට ලියන්න පුළුවන් නම් I කියන්නේ හැම වෙලාවම identity matrix එක. 1 is in the real world, but in the matrix world it is identity matrix. Right? එතකොට x කියන එක ix විදිහට ලියුවා කියලා වරදක් නැහැ. Right? There's no problem when we write x as ix. I means identity matrix time x. Identity matrix time x means x ම තමයි. Right? So then, what I will be doing is I'm taking whatever on this right hand side to the left hand. දකුණු අත පැත්තේ තියෙන ටිකක් වම් අත පැත්තට ගන්න. X minus k means lambda ix. Next. Any factors? Are there any factors, students? If so, what is the factor? සාධක තියනවාද එහෙමනම් මොකද්ද? X. So I am writing right. So actually this is where we need to come. And මෙතනට තමයි අපට එන්න ඕනේ. A minus k means lambda. A minus lambda I times x is equal 0. Right? Thus, the unknown scalar lambda is known as eigenvalue of matrix A, and the corresponding non-zero vector x is eigenvector. Then what a number right? Now, name changes are coming. Right? Here, lambda is called the eigenvalue. So here, lambda, in my case, it's k. Lambda is called eigenvalue of matrix A. A කියන matrix එකේ eigenvalue එක තමයි lambda. ඒ වගේම x කියන්නේ eigenvector එක. So, within a question, we have to separately find out the eigenvalues, and we need to separately find out the vectors corresponding to the eigenvalues. Everyone. Another thing is eigenvalues, characteristic values, latent values. Right? Same thing. So whenever you are referring to the reference books or whenever you find the questions or theory from the internet, you will come across the words like characteristic value, latent value. Both are means eigenvalue. Right? The eigenvalues are called characteristic values. Again, proper values again. Proper values. Eigenvalues, characteristic values, latent values, and proper values. Right? The eigenvalues are also called, right? And so let's assume this is the matrix. Right? Let's assume this is the matrix. Right? Let's assume this is the matrix. Right. So here I think you can remember we have come across අපට ආවා A minus ki times x is equal 0. ඔක තමයි අවසානයේට අපි ගත්තේ. Now A minus lambda I or A minus ki කියන්නේ what is A? A is the original matrix 2 2 1 1 3 1 1 2 2. So this is the matrix. Minus lambda. So you know that lambda is a scalar. දැන් ඔයගොල්ලෝ දන්නවා lambda කියන්නේ scale එක. මොකද scale එක කියන්නේ 1 2 3 4 5 100 200 300 ස්කේල් එක. වෙක්ටර් එකක් මැට්‍රික්ස් එකක් නෙමෙයි ස්කේල් එක. මොකක්ද number එක. Right? So lambda times what is I? I is the identity matrix. So if your original matrix is 3 by 3, make a 3 by 3 na, ඔයා මෙතන ලියන්නත් ඕනේ 3 by 3 identity matrix එක. If here you have 4 by 4 matrix, then here your identity matrix should be changed accordingly. If it is 4 by 4, this is 4 by 4. If this is 5 by 5, this is 5 by 5. Right? If this is 2 by 2, this is 2 by 2. Right? So see this 3 by 3 matrix A minus lambda times 3 by 3 identity matrix, which is equal, then method subtraction. Right? Before to the subtraction, there's a scalar multiplication. Right? Subtract කරන්නත් කලින් තියෙනවා scalar multiplication එක. කොතනද? එතන. මෙතන තියෙන scalar multiplication එක. Right? So here, this has the scalar multiplication. Got the scalar multiplication? This is a scalar, you know. Lambda කියන්නේ scale එක. Scale එකෙන් මේ ඇතුළේ තියෙන ඔක්කොම වැඩි වෙනවා. So then you can see all the non-diagonal elements 0 0 0 0 0 0. All the non-diagonal elements are 0. All the diagonal elements are 1. So that is the meaning of identity matrix. So when you multiply identity matrix by lambda, එතකොට මෙන්න මේකත් lambda වෙනවා. Right? This also become lambda. Right? Right? Anyway, this becomes lambda, this becomes lambda, this becomes lambda. Right? So along the diagonal, all these ones are converted to lambda. Then, so here, now what you have to perform a subtraction. This matrix subtract this matrix. So then you will get, finally, after the subtraction, you will get 2 minus lambda, 2, 1, 1, 3 minus lambda, 1, 1, 2, 2 minus lambda. So that means only the diagonal elements of the original matrix is changed as 2 minus lambda, 3 minus lambda, 2 minus lambda. මේ diagonal elements වලට minus lambda එකතු වෙච්ච එකයි උනේ. 2 minus lambda, 3 minus lambda, 2 minus lambda. So finally, this particular matrix, we call it as characteristic matrix. What is it? Characteristic matrix. So these lambda value is called the eigenvalue, characteristic value, proper value, latent value. However, the matrix including the lambda, we call it as characteristic matrix or eigen matrix, proper matrix. Right. So next. Right. So after you have obtaining the characteristic matrix, right. So next thing is you are going to find the determinant of this characteristic matrix. Right? Characteristic matrix එක ආවයින් පස්සේ determinant එක හොයනවා. So right. So then can you please calculate the determinant of this particular matrix? Determinant එක හොයලා කියන්න බලන්න. ඔයගොල්ලන්ට value එකක් එන්නේ නැහැ because there is lambda, but when you further solve it, simplify කරලා solve කරොත් ඔයගොල්ලන්ට එනවා යම්කිසි ප්‍රකාශනයක්. You will get a mathematical expression. I need that one. Solve it and tell me what is, so that means basically you have to find the determinant with this including lambda. What is the mathematical statement that you will get? I got one answer. At the time, I'll go to the right. So this is what you should get. Right, when you find the determinant of this particular matrix, including lambda, you will finally end up like this. Maybe you will get a mathematical expression like this. For this thing, we call it as characteristic polynomial. So this original thing, a minus lambda I, so almost all the elements minus lambda, this is called characteristic matrix. So lambda is called the characteristic value. This is called the characteristic matrix. And here now the expression that we have taken out of the characteristic matrix, we call it as characteristic polynomial. Characteristic matrix එකෙන් determinant එක හොයලා ගත්ත mathematical expression එකට අපි කියනවා characteristic polynomial. Characteristic polynomial of the matrix A. So then when this particular mathematical expression, when we make it equal to 0, make a බිඳුවට සමාන කරාම, so this will become characteristic equation. Right? The equation, this thing is 0, is called the characteristic equation. Right? So when we find the root of this particular equation, whenever we given a equation, nonlinear equation, this is a nonlinear equation, right? Lambda to the power 3 minus 7, lambda to the power 2 plus 11, lambda minus 5 equals 0. මෙතන තියෙනවා maximum degree of 3. මෙතන උපරිම degree එක වුණා නම් මේක linear equation එකක්. So since this is more than 2 or more than 2, this is a nonlinear equation. So if we are going to find the root of this nonlinear equation, so the root that we taken is called it as characteristic roots or eigenvalues. දොර අපි මෙතන මේ equation එකේ root එක හොයනවා කියලා හොයන්නේ ඇත්තටම lambda values. අපි දන්නවා lambda කියන්නේ characteristic value or eigenvalue. So finally, by solving this particular characteristic equation, we are able to find this characteristic roots or eigenvalues. Now you can see eigenvalues are just numbers. Eigenvalues are scalar values scalar. So here you can see here you have obtained 3 roots. 2 are similar, 1 is different. 1, 1, 5. 2 are similar, 1 is different. So here you have learned about what you mean by characteristic matrix. How to obtain characteristic matrix. Whenever you give a matrix එකක් දුන්නොත් ඒක characteristic matrix එකක් කියලා convert කරන්නේ කොහොමද? So this is the process, but you do not need to do everything. මේ ඔක්කොම calculations කරන්න ඕනේ. What you have to do is you just put minus lambda to almost all the diagonal elements. දීලා තියෙන matrix එකේ diagonal elements වලට minus lambda දාගෙන යන්න. So then the same matrix is converted to characteristic matrix. Then when we find determinant of that matrix, so that statement is called the characteristic polynomial. When we equate this characteristic polynomial to 0, make equation එකක් බවට පත් කරාම සමානයි බිඳුව දාලා. So that is called as characteristic equation. And after, when we solve the characteristic equations and find the roots, those roots are the values for the eigenvalues. That means values for the lambda. Lambda තමයි අපේ eigenvalues. Right. So next, important properties of eigenvalues. Right, important properties of eigenvalues. In this square matrix A and its transpose A inverse have same eigenvalues. If there's a matrix called A, and if we transpose that matrix, and again we find the eigenvalues of the transpose matrix, then not the eigenvalues. So in an MCQ, these are MCQ hints. In an MCQ, if you are given the eigenvalues of a particular matrix and asked you to calculate the eigenvalues of the transpose, you do not need to calculate because both eigenvalues are same. Right. Second one. The sum of eigenvalues of a matrix is equal to the trace of a matrix. So trace Sum of elements on a principal diagonal of a matrix is called the trace. Trace එක කියන්නේ principal diagonal එකේ තියෙන elements වල එකතුව. So if I go back, so what is the principal diagonal? This one, 2, 3, 2. Make a diagonal, principal diagonal. So if we add them, that value is called the trace. Right? A trace එක සමානයිලු sum of eigenvalues of a matrix. Right? Sum of eigenvalues of a matrix. උදාහරණයක් විදිහට බලන්න. So here as an example, you by yourself you can check. Here now A. This is a A matrix. What is the principal diagonal? This one. What is the summation of this? Or else I'm asking, what is the trace here? Trace here is summation of the elements of the principal diagonal. So what is the trace here, students? Make a trace here. Go. Trace here. Huh? I didn't get it. What is the trace? One answer. 7. Yes, 7. What was the 7 now? 2 plus 3 plus 2. Right? 7. දෙක 3යි 2යි 5යි 2යි 7යි. එතකොට මේ matrix එකේ trace එක 7යි. Now what are the eigenvalues? Then මේ eigenvalues එවුවනේ අපි මේකේ. මේකේ eigenvalues ටික තමයි 115. So now get the summation of the eigenvalues. Eigenvalues ටික එකතු කරලා බලන්න කීයද එන්නේ කියලා. 1 plus 1 plus 5. Again 7. Now you can see the trace. Or else the summation of the elements of the principal diagonal. Or else අපි තනි වචනෙන් කියනවා trace එක 7යි. And although when you get the summation of the eigenvalue of the same matrix A, both values are same. 7යි. So that is what they are saying. The sum of eigenvalues of a matrix is equal to the trace of the matrix. So if someone asks what do you mean by a trace? Trace is the summation of elements on the principal diagonal of a particular matrix. Right. So the third one, the product of the eigenvalues of matrix A is equal to the determinant of A. The product of the eigenvalues of the matrix A is equal to the determinant of the A. So the fourth one, lambda 1, lambda 2, lambda up to n are eigenvalues of A, then eigenvalues of, right. දැන් අපිට තියෙනවා matrix එකක් A කියලා. හරිද? A කියන matrix එකේ eigenvalues lambda 1, lambda 2 up to lambda n. අපි හිතමු 1 2 3 කියලා. A කියන matrix එකේ lambda values වෙන්නේ 1 2 3. එහෙමනම් so if we ask to find KA කියන matrix එකේ lambda values මොනවාද? Originally we have a matrix, right? Originally we have a matrix A and lambda values are 1 2 3, right? If I will be given a matrix called KA, ඒ කියන්නේ A කියන matrix එක K කියන scale එකෙන් වැඩි වෙලා. අපි හිතමු K කියන්නේ 2යි කියලා. එහෙනම් මෙතන 2A වල eigenvalues වෙන්නේ මොනවද? Originally A ගේ eigenvalues 1 2 3 නම් 2A ගේ eigenvalues මොනවද? Anyone? Anyone? මේවා තමයි original eigenvalues. එහෙනම් K කියන්නේ 2යි නම් 2A ගේ eigenvalues වෙන්නේ මොනවද? 2A කියන matrix එකේ. හරි. 2 4 6. හැම eigenvalue එකක්ම 2කින් වැඩි වෙනවා. right? So A inverse, then A for A, eigenvalues are 1, 2, 3, right? For A inverse, 1 divided by lambda 1, reciprocal, like 1 divided by lambda 2, 1 divided by lambda n for A inverse. Right? A eigenvalue for A inverse. What are the eigenvalues of A inverse? What are the eigenvalues of A inverse? Cool. What are the eigenvalues of A inverse? 1 divided by 1, 2 divided by, 1 divided by 2, 1 divided by 3. Right. If A has eigenvalues of 1, 2, 3, then A inverse, the eigenvalues in 1 divided by 1 can 1 by half and 1 over 3. And again, if A has eigenvalues of 1, 2, 3, A to the power m are, A to the power m here matrix eigenvalues lambda 1 to the power m, 2 to the power m, up to lambda n to the power m. Now I am asking if A has eigenvalues of 1, 2, 3, what are the eigenvalues of A to the power 2? A to the A squared matrix eigenvalues මොනවද? A squared කියන matrix eigenvalues මොනවද? 149. Right. 1, 4, 9. Right. So these are all of these are especially very important for MCQs. Whenever you are given a matrix and matrix along with its eigenvalues, and if you ask to find the eigenvalues for the transpose, same eigenvalues. And also if you are given eigenvalues of a particular matrix and ask you to find KA, A inverse and AM, you do not need to calculate again. ඔගොල්ලෝ දැන් eigenvalues calculate කරනවා කියන්නේ මොනවද මොකක් කරන්න ඕනද ළමයි? Right? What you have to do? You need to create like this, get the polynomial, make it into equation, and you need to solve this particular equation. මේ equation එක solve කළා තමයි මේ eigenvalue තුන ගන්න ඕනේ. ඔය ඔක්කොම කරන්න ඕනි වෙන්නේ නැහැ මෙන්න මේවා දන්නවනම්. Right? So whenever you are given the eigenvalue of a and ask you to find Ka, A inverse A to the power 2, you do not need to go from the beginning, right? From the eigenvalues you have, you can predict for Ka, A inverse A to the power m, and also for the transpose, you can predict. Right. So for this one, yeah. For this one, students, actually, yeah, you can, right. So find the characteristic roots of the matrix. So for this one, I am suggesting you, firstly, actually, you need to find the eigenvalues. The method you will eigenvalues done. Before proceed to the eigenvalues, now tell me what is the characteristic polynomial or the equation you get after you find the determinant of this particular matrix. So that means first you need to convert it this to a characteristic equation. Over the characteristic equation, you're going to convert karane, right? You select this diagonal elements and you make it to minus lambda. 6 minus lambda, 3 minus lambda, 3 minus lambda again. right? So then after converting this particular matrix to a characteristic matrix, you need to get the determinant, find the determinant. So there you will get the characteristic polynomial. Right? Then when you make it equal to 0, you will get the characteristic equation. By solving the characteristic equation, you will be finding the characteristic roots. Right? So this is the characteristic equation. So this particular original matrix, right? So the diagonal elements, 6 minus lambda, 3 minus lambda, 3 minus lambda. So here we have done it. Then you need to find the determinant, right? Determinant and make it equal to 0. Right. So this is, you have found the determinant, and this, by solving this, you need to find the characteristic. So values or eigenvalues hොයන්න මේක විසඳලා. Right? So again I am telling you, right? Right. So when you solve this further, so this is the determinant equals 0, and when you solve this further, make ඔයගොල්ලෝ further solve කරොත් ඔයගොල්ලෝ එන්නේ මෙතනට. This is the characteristic equation where you will end. Minus lambda to the power 3 plus 12 lambda squared minus 36 lambda plus 32 equals 0. Normally, if you have system of 3 equations, you will get a characteristic equation like this. In the previous case also, කලිනුත් ඔයගොල්ලන්ට මතක ඇති මෙතනදිත් ආවේ degree එක 3 වෙච්ච equation එක. So this is what you need to further solve and find the roots. මේක තමයි මෙතනින් තමයි ඔයගොල්ලෝ roots හොයන්න ඕනේ. By solving cubic polynomial, cubic equation එකක් solve කළා තමයි you need to find the root of this particular matrix, characteristic matrix. එහෙම නැත්නම් eigenvalues හොයන්න ඕනේ මේ cubic polynomial එක solve කරලා. Right? But I know that there are some students who are capable of finding roots of this equation, but most of you may be thinking how to proceed. ගොඩක් අය හිතන මොකද මේ කරන්නේ? Right? This is not, so one method that you can go for is the long division. දීර්ඝ බෙදීමට යන්න පුළුවන්. Right? You can adopt long division and then you will find the answer. But that is again bit tough. Right? So I myself will have introduced a very easy method rather than you come here. Right? මගේ method එකක් මම introduce කරනවා. Right? So before you come to this step, right, you can easily finding the roots of this particular equation. Right? How? This is the hint. Right? So after you find the determinant, මෙතනදී ඔයගොල්ලෝ කරන්නේ determinant එක හොයන එක. Right? So here they have found the determinant with respect to the first row. First row එක අනුසාරයෙන් තමයි determinant එක හොයලා තියෙන්නේ. Right? 6 minus lambda times 3 minus lambda, 3 minus lambda, this thing, minus 1 minus 1 plus 1. Again minus 2 times, what happened? Then plus 2 times, what happened? මේ හොයලා තියෙන determinant. Right? So after you obtain this one, a same thing තමයි මේ මෙතන තියෙන්නේ. එතන තිබ්බ එකම තමයි මෙතන තියෙන්නේ. Right? What you have to do is, right, rather than solving it further, then කලින් කරේ, right, what have you done? ඔයගොල්ලෝ මේක තව දුරටත් solve කරලා විසඳලා වැඩි කරලා, so by removing the brackets, 6 times 9 and 6 times 6 lambda, 6 times lambda squared, 6 times minus 1, and then minus lambda times 9, minus lambda times minus 6 lambda. ඔය විදිහට වැඩි කරලා තමයි cubic polynomial එක ගන්න. But my advice is not go like that. So after you come here, what you have to do is you need to factorize. මෙතන ඉඳලා මොකද factorize කරන්න පටන් ගන්න. For example, you can find the factor of this thing. Right? X squared minus 6x plus 8. You can factorize it. Make a factors කරන්න පුළුවන්. And here, right? Here, that is also further you can take common factors out. Here, same. Right? Right now, when you further factorize, you will see like this. ඔගොල්ලෝ මේක තවදුරටත් further factorize කරොත් ඔගොල්ලෝ මෙන්න මෙහෙම දෙයක් දකිවි. Right? There are basically problem in the mouse. Oh. Go that. Right, yes. Anyway, so here you will see there are 3 separate terms here, right? Method terms තුනක් තියෙනවා. Right? You will see 3 separate terms here. Right? You will see 3 separate terms here. 1, 2, 3. Right? So this is corresponding to this one, this one, this one. Right? So මේ terms තුනට සම්බන්ධව තමයි මෙහෙම ආවේ. So here we further factorize, right? Rather than multiplying and removing brackets, වරහන් ඉවත් කර සුළු කිරීමට වඩා අපි කරේ තවදුරටත් factorize කරා. When you look at these 3 terms separately, you will identify there's a common factor. Right? So from this particular first term, x minus 2, from second term again x minus 2, again from third term x minus 2. So for both 3 terms, for all 3 terms, x minus 2 is common. So as the next step, what you are doing, right? You will take that common term out. A common term එක out කරගන්නවා. දැන්ටමත් එතකොට ඔයගොල්ලෝ එක eigen value එකක් හොයාගන්න. So for now you have found the first eigen value. So now what you have to do is you need to solve whatever within the bracket. Now ඔයගොල්ලන්ට කරන්න තියෙන්නේ මේ ඇතුලේ තියෙන දේ solve කරගන්න එක විතරයි. Right? So if you closely look at whatever inside there here, right? Whatever inside here, you need to further solve this, right? So already you have taken one common factor out. You need to further solve this, right? Whenever you further solve this, so after solving whatever in this ellipse, solve so this is again easily factorizable. How? Right? So now you have come up with all the 3 factors. Lambda is equal minus 2 plus 2 and 8. Right. Now here you have understood you do not need to solve a cubic polynomial to find the factors or find the eigenvalues. Right. If you are confident of solving a cubic polynomial, it's okay. Right. Cubic polynomial like solve karana confident now, solve karana kamak nahi. But if you think that you are unable to solve a cubic polynomial, so don't go that 10, right? You so just after you find the determinant, right, you can factorize all of them and take the common term out, and you can finally you will end easily, you will end to the factors. You do not need long division and all, right? This is one of the easiest way where you can find the factors of a cubic polynomial, right? Of a cubic polynomial. Right. Okay. So after here you will get the make of Visanduatekai. So here by solving this cubic polynomial, you will get the same answer. Right. However, the method I have introduced you is very easy rather than solving cubic polynomial. Right. So from here, we are going to stop for today. Right. So later on, we have to learn we have to go for so complex calculations under characteristic equation or eigenvalues. So later on, we are going to find eigenvectors corresponding to each of these eigenvalues. May have eigenvalue eigenvector. Later on, we are going to construct P matrix. Out of that, we are going to diagonalize that P matrix. Out of that, we are going to find the powers of the matrix, say the power 4, 5, 6, or whatever. Right? So next week we'll continue the rest of the day. So thank you for joining with the lectures. Now on you can send the messages for attendance. So those who have sent me the messages, you can leave the lecture. Thank you.
Excuse me, madam.
Yes. Okay.
Factorize වෙන equation දෙන්නේ අපේ ගණන් වල.
මොකද?
Equation හරියට factorize වෙන ඒවත් දෙන්නේ.
Oh, mostly you will get equations where the factors you will get easily. Easy factors මේ කැඩෙන විදියට තමයි equations එන්නේ. ගොඩක් වෙලාවට දෙන්නේ මොකද ඕගොල්ලන්ට දැන් මෙතන බොහොම සරලයි වගේ පෙනුනට, so although you can see this is very simple up to now, it's very simple, but later on based on these three eigenvalues, as I told you, you are going to find three eigenvectors out of that P matrix, then diagonalize P matrix. මේ සාමාන්‍ය මේක ප්‍රශ්නයක් A4 වල එකමාරකට වඩා දිගයි. සෑහෙන ලොකු calculation එකක් යනවා. ඒතකොට එතනදී අර factors හරියට factors වෙන ඒවා තමයි අපි දෙන්න ගොඩක් වෙලාවට උත්සාහ කරන්නේ. එහෙම නැතුව ඔයගොල්ලන්ට ප්‍රොසීඩ් කරන්න අමාරුයි. question එක. So therefore you do not need to worry about that.